Hello, here is a solution calorimetry example for you. In it, we're going to take some ammonium nitrate solid and add some water to make a solution, and do all of this in a coffee cup calorimeter while measuring the temperature. And in this case, the temperature decreases from 25.0 degrees Celsius to 21.1 degrees Celsius. We're going to use the information to calculate the enthalpy change, delta H, for this process, units of kilojoules per mole. We're going to use some additional information, the density of the solution and the specific heat of the solution. As a picture to help you understand, all you got to do is take that cork lid, remove it, add your ammonium nitrate and water, replace that lid, and monitor the temperature. Also, remember, calorimetry is used to determine the heat change for a chemical reaction. Here it's technically a process that's taking that solid ammonium nitrate, adding it to water, and that causes a separation of the ions that make up ammonium nitrate. If we can calculate the heat involved, we have a complete thermochemical equation. We're going to start off by calculating the heat of the solution using the equation above. It's mass times specific heat times delta T. Remember, delta T is final minus the initial temperature. All the values are input into the equation at the bottom. The 25 milliliters of solution is replaced by 25 grams because the density of the solution is 1 gram per milliliter. Also notice that the final temperature is lower than the initial temperature, so the value of Q is a negative value, negative 407.6 joules. What this means is that the solution loses that many joules of heat. Remember, this process involves a heat transfer. Heat transfers between the solution and the reaction. Here the reaction is the ammonium nitrate. If the solution loses heat, well, then the ammonium nitrate, the reaction, gains it. So the heat of the reaction is a positive value, 407.6 joules. Our next step is to calculate how many moles of ammonium nitrate are present. The amount of heat absorbed depends on the moles of ammonium nitrate. This is a very simple calculation. We're just dividing the mass of ammonium nitrate by the molar mass, 80.05 grams per mole. We get our answer in moles. We have everything we need to calculate delta H. We take the joules and divide by 1,000, which moves the decimal place 3 places to the left, divide by the moles. We get a value of positive 26.1 kilojoules per mole. We use this value to complete our thermochemical equation. What this says is the dissolution of ammonium nitrate in water is an endothermic process. It takes heat to get this done. The heat comes from the solution. All done.